Hello everyone, welcome to this video. Today in this video we will be talking about the third part of your 14th unit, and this is heat transfer. Now let us start off by considering this very important point over here in your textbook. Now, as I had reminded earlier, this note is your textbook and I have highlighted some important things, and I shall be doing this lesson using the textbook so that you all will have a clear idea how to refer the textbook and what are the important parts in the textbook, and also to help you all with how to make your own notes. Now without any delay, let us start off with the lesson. Now here it says that heat is a type of energy. Now in our environment, there are various things. You get rocks, you get water, you get buildings, you get trees, and then at the same time you get heat, wind, light. There are so many things in the environment. So things in the environment, or substances in the environment, we can categorize them into two categories. One, energy, and the second one is called matter. Now matter is anything that occupies a space and has a mass. For an instance, a rock. You can take a rock, or a building, or a car. Anything that has mass and will occupy a space is what we call as matter. Then when you consider energy, anything that doesn't occupy space, no space is occupied by energy, and there is no mass for this energy. So anything without space and mass is what we call as energy. For an example, heat. It has no mass and it doesn't occupy space, it's just there. And then you can take sound. Sound doesn't occupy space and it doesn't have a mass. And all these are forms of energy, and heat is a type of energy. Now what is the largest source of heat? The largest source of heat is the sun. So that is the biggest fireball that's there in our entire solar system, in our entire galaxy. So that is the biggest form or source of heat. Now we must understand that heat can travel from one place to another, and when heat goes, for an instance, when you consider this, if this is the sun, let's just consider this is the sun, and here you get all these planets and earth. So heat from this sun will transfer or will travel from the sun to the earth and to all these planets, right? So this transferring of heat, again heat I will be representing with this triangle to show heat. Heat is transferred from place to place, and this transferring of heat is what we call as heat transfer. Now this heat transfer, as you can see here, heat transfer can occur in three different ways: conduction, convection, and radiation. Now we will be talking about how heat is transferred by conduction, convection, and radiation in a bit detailed manner. Now to start off with this, we are going to talk about conduction. Now one of the day-to-day incidents of conduction is when you are, for an instance, say cooking, or when you are frying an egg, you will notice if you use a metal spoon and when you keep it on the pan, or let's say on a hot cup of tea, you put a metal spoon, and when you keep it there, you will notice that this metal spoon is starting to get hot little by little. The far end of the metal spoon, like here, now anyway the tea is hot, so over here the metal spoon is hot, but little by little this area also will start gradually increasing the heat. Again here gradually the heat will increase. Here it's anyway hot, but here it's cold and the heat will keep on increasing gradually. So this is an example for conduction in our day-to-day lives. Now we are going to do activity 14.8 to find out how heat is transferred through a solid substance. Now normally in your textbook they will tell let us do activity 14.8, or they will give a number to find out how heat transfers through a solid substance. So normally this is yours aim. So if they say describe an activity, you have to start off by writing the aim, materials you need, the method, observation and the conclusion. Now here you can see the aim and it's clearly given here. Let us do activity to find out. The word to find out is the key we use to identify the aim. So now to do this practical, we are going to need a metal rod, as you can see here, a metal rod about 20 centimeters long. So this you need like this way, a metal rod, and it should be something around at least say 20 centimeters long, and you will need some pins and of course a candle. Now what you're going to do is you're going to take this rod. So now what you're going to do is you're going to take this 20 centimeter long metal rod, and then you're going to mark 2 centimeter intervals like this. So you can use a ruler and measure 2 centimeter gap. Okay, this way you have to do. You have to mark 2 centimeters. Then you can light a candle, okay, like this, and drop some wax onto these time intervals. Every 2, you must keep a gap between each of these drops, and the gap should be 2 centimeters wide. And then you're going to take these nails and you're going to fix this while the wax is still hot. And then when the wax is hardened, these nails will stick onto the metal rod. And then what you're going to do is you're going to turn this upside down like this way and light a candle on the far end of the rod. Then you will notice that little by little, so you will notice that first this nail closest to the candle will fall as the wax melts. Then over time this will fall, then this, then this. Like this, these nails or pins, you can use pins even, will start falling little by little. Now be careful when you use pins, because these things could accidentally prick you all. So be very careful when you all use this. It's better to dress some protective gloves also when you use this. Then we can record our observation, which I just explained. Now in your textbook they normally give the conclusion and the observation. How do we find it? So to find it we have to do a bit of reading. So normally they might give you can observe. They will say something like this, which points us towards the observation. Okay, so here pins are dropped down gradually starting from the heated end of the rod because of the melting of wax. That is the observation, and that is what I explained. So when the rod is kept like this, these are the pins with a 2 centimeter gap each has 2 centimeter gap, okay, and this is 20 centimeters long, a metal wire, and you lit a candle here. So little by little this wax will start melting and this pin will fall down. This wax will start melting, this pin will fall down. So like that, from the far end, from the point or from the end where the candle was lit and metal rod was heated, pins will start dropping gradually as the wax melts. So that is our observation over here. Then here you can see, thus it can be concluded. Normally here they use the word concluded. Observe to tell us what it is. Here is the conclusion. Heat has transferred through particles of the rod starting from heating end. So heat, okay, here the heat has transferred from this heating end and it has kept on going like this. That's our conclusion. Okay, now with that that is our conclusion for the practical. Now using this knowledge, there is something special we can identify. That is, this method of transferring heat from particle to particle, without the motion of particles, through a solid is known as conduction of heat. So simply, conduction of heat is the transfer of heat through solids. That is the simple definition. But if the most elaborate or the most accurate definition would be transferring of heat from particle to particle without the motion of particles through a solid. This is what we call conduction of heat. Now what do you mean by particle to particle without motion? Now if you take that wire and if you observe it carefully, you will notice that if it's a metal wire, it's made up of a group of metals. Let's say you took a copper wire, then it will have lots of copper ions in it. Or if you took a nichrome one, it will have nichrome stuff in it. So like this, there are small substances in it. And if it's a metal, normally you get free electrons in this. Now this is a bit of a complicated thing, and you all will be learning more about this, especially in your grade 10 syllabus and 11. But just for y'all's knowledge, just remember, a metal rod comprises of teeny tiny little metal particles, and these metals are the one that form this huge rod. Now heat will move from this to this to this to this. Like this, heat will keep on moving from these particles to particles without the motion of particles, and these will be stationary. They won't move because they are fixed. They are normally located like that, and metals are normally like, you call it a giant metallic lattice. So those are complex things you all don't need to know. Just remember, there are teeny tiny little things that make up a metal rod, and heat is transferred from these small particles from one particle to another without the motion of the particles through a solid. Okay, so the most of the metals conduct heat well. Now metals, normally you have something called the periodic table, that also you all can later on recognize and identify those, especially in your higher grades. So metals conduct heat well, and they are called heat conductors. So when anything conducts heat, we call it a heat conductor. Just as if something conducts electricity, we call it an electric conductor. Examples for heat conductors are copper, aluminium, gold, silver, iron. Okay, so very important things here is copper is the most important one here. Again, iron and aluminium. Gold, silver is also important, but mainly remember copper. Now you must also understand that there are various substances that do not conduct heat well, and they are called heat insulators. They prevent heat from being transmitted from one place to another. Example, you can take glass, wood, plastic, cloth, air, water. These things act as heat insulators, and they do not let heat transfer from one place to another. For an instance, when you use a wooden spoon, and if you keep it in a cup of tea or in a pot that is very hot, if you touch the spoon handle, only the place you will notice it's not that hot. Due to the radiation and stuff, the air will be hot, so your hand might feel hot, but the stick itself or the wooden spoon itself is not hot. So it's a heat insulator. And here you can see some pictures, okay, of heat conductors and heat insulators. Now here they say plastic is a heat insulator, so that's why you can see some of the ions that are made out of plastic. Okay. Now another important and interesting fact is, you must have seen these people living in cold countries. They have this woolly clothes. No, you can see it's like very puffy. It's having a lots of wool in it. So these woolen clothes are good heat insulators. So the heat inside their body will not be lost outside. It will accumulate in the suit and it will be trapped there, and cold also will be sort of somewhat prevented from entering in. Then our next one is convection. So conduction was transferring of heat in solids. Convection is what we are going to talk about now. So now heated air near, now if you look at this figure, you will notice, and if you have seen this, if you burn something under a tree, you might notice that these branches on top start to move little by little. Okay, so for an instance, say you're burning some dirt over here. Okay, here is some dirt and you're burning it all, and this dirt you're burning is under, let's say, a coconut tree. Okay, so just bear with me, my drawings. Bear with my drawings. Okay, everyone. So yeah, heat will transfer like this, and then these branches will start to shake. They will move. So heated air near the fire rises up. Okay, this heated air is near the fire. Okay, and this heated air that's near the fire, it starts to, this heated air will start rising up, and then up there is cool air, right? The cool air will start coming down. Hot air will go up, cool air will come down and will flow towards the fire. So heated air currents rising up like this is what we call as convectional currents. So this heated air that travels up, goes up, is what we call convectional currents, and these currents will strike these twigs and these branches of trees, and then these things will start to move. Now let us do a small, now as I said earlier, we are going to do activity 19.4 to study further about the ways that heat travels through air. Let's see. That was our aim. We are going to see how heat is going to travel through air. This is an interesting practical. You can do most of these at your home also. Now for this you will need a tall beaker, as you can see here, a cardboard, a candle, and some joysticks. You are going to cut the cardboard to a shape like this, you can see. So you can take a huge cardboard and you can just cut a small shape that's similar to this. Okay, once you cut this out, you're going to take this cardboard and you're going to place it in that huge beaker right in the middle of it, like this. You can see over here how they have placed it like that. You're going to place it inside the beaker, and then this thing is going to divide the beaker into two chambers. You can see A chamber, B chamber. This also I'll put A chamber, B chamber. Then we are going to place a lighted candle, like you can see here, let's say in chamber B or side B, and then we are going to light up some joysticks, like you can see here. Joysticks are what in Sinhala we call handun kuru, and then we are going to light up and let the smoke enter side A. Then we are going to observe. You will be able to observe something like this, that this smoke that's coming down starts to move upwards from chamber B. Chamber A smoke falls down, and from chamber B it starts moving upwards. Okay, so that is going to be our observation. Now for further clarifications, they also have given an observation here. Smoke of joysticks enters the beaker from side A and comes out from side B. When heated air rises up from chamber B, lighted candle is placed. Where heated air rises up from chamber B, when heated air rises up from chamber B, where the lighted candle is placed, cool air flows down into the chamber. So when heated air rises up from chamber B, cool air flows down into the chamber A. It is clear that smoke of the joysticks also flows with air current. So you can see when this smoke goes down from this and comes up from here. Now hot air is put out and then cold air comes in. Heated air is putting out from chamber B, cold air is going to enter chamber A, and then you will notice smoke also is traveling in a current, and then later on we can come to a conclusion which is over here. Thus it is clear heat travels through air as convectional currents. Okay, so So traveling of heat through air is what we call as convectional currents. They travel as convectional currents, and that is related to, like we discussed earlier, convection. Now the next thing is we are going to identify how heat travels through a liquid. For this we are going to take some condensed crystals. So you can get these condensed crystals in your laboratories. It's a pinkish colored beautiful crystals, and then you need a candle or a Bunsen burner, and you will need a round bottom flask. Now here you can see a round bottom flask. Why do we call it round bottom flask? Because the bottom of it is round. And then we are going to need a laboratory stand, as you can see here. We are going to place some condensed crystals at the bottom of the round bottom flask, and we are going to cover it with some wax. We are going to take a candle, light it up, and cover this thing with wax. Then we are going to pour water into the flask and then heat it. Then we will be observing what happens. Now you will notice that heated water rises up and cold water comes down, and the condensed crystals covered with wax are over here, and you will be able to identify this using these condensed crystals. The condensed crystals will show us the path or the wave. So now here you can see it can be observed that purple colored lines rises up as currents from condensed crystals in water and sinks down near the flask. Here water at the bottom of the flask is heated and rises up because the reduction of its density. Meanwhile, cold water at the top sinks down because it's a higher density. So now what is density? Now density is something really complicated. In simple, the density of a liquid is the mass of a liquid over the volume. Mass over volume. So here you can see they say it can be observed that purple color rises up as currents from condensed crystals in water and sinks down near the wall of the flask. Now this is what I had explained earlier about how condensation helps us to recognize the convectional current. Here water at the bottom of the flask bottom is heated, and hence it rises up because density is reduced. So simply just remember, as heat increases, density is normally given by this symbol that looks like P, which is rho. Okay, it decreases. So when density decreases, it's going to increase floating more. It will float more. Floating increases. So when the heat increases, density decreases, so it will float. Therefore the hot water is going to come to the top of the flask, the hot one. Okay, it will come to the top. Then cold water at the top sinks down because density is higher, and when heat is low, density is high, then flotation or floating of substances is low. That means this cold water, what happens is the up you get cold water, it comes down, and you can recognize this using condensation. Then we can the rising heated water currents and sink cold water currents are known as convectional currents. Okay, so this rising of heated water currents and sinking of cold water currents is what we call as convectional currents, that we must remember. Water in a flask heats because of these convectional currents. Now one of the interesting things is that they can sometimes give you a figure of a flask and explain how heating occurs. Okay, how does water boil in a flask when it's kept on a stove like this? So you have to explain that first the metal flask will conduct heat, and then from the metal flask surface the water in it will have convection of heat. Heat will enter the water and there will be convectional currents, where due to heating water's temperature increases, then density decreases, therefore hot water will move up, and then cold water is low in the temperature, therefore its density is low, therefore floating is low. That means it will go to the bottom and get heated, and this will happen until all of the water reaches 100 degrees, which is the boiling point, and then it will start to toot. You will hear the kettle boiling. So this is a very famous question they normally ask, and this was something really important because there was a question like this even for the O levels. So this is something you should remember very carefully. The ordinary level one was a bit complicated, but this is a basic idea about it. Okay, so the method of transferring of heat through liquids and gases by convectional currents is what we call as convection. Okay, so the method of transferring heat through liquids and gases by convectional current is what we call as convection. Okay, so that we must remember. Okay everyone, so the next topic is going to be application of convectional currents. So here we will be talking something very important, which is very much important, so much so that it even is questioned for your ordinary level exams. So if you get a basic idea about it now over here, it will be very useful for your O-level studies. So this lesson will be covered in my next video. This part of the lesson we will be talking about radiations, land breeze and sea breeze, and we will be talking about this how conduction occurs, convection, radiation is all affecting, and we will again summarize everything, and we'll do the exercise in the next video. So for this video, that's it. Hope you all enjoyed the video, understood the lesson. If you all did, don't forget to like my videos, subscribe to my channel if you are new, and share my content with your friends. So until next time, bye.